Welcome back to our channel, where we explore the mysteries of the universe. Today we're taking a deep dive into the world of quantum physics and exploring the groundbreaking theory of Max Planck, one of the most important physicists of the 20th century. Planck's quantum. At the turn of the 20th century, scientists struggled to understand the phenomenon of black body radiation. This seemingly simple problem led to a revolution in physics, as Max Planck proposed a theory that would change the way we think about the nature of energy and matter. Planck's quantum hypothesis, which proposed that energy could only be released or absorbed in discrete packets, or quanta, paved the way for the development of quantum mechanics. In this video, we will explore how Planck's theory of quantization of energy has contributed to our understanding of the fundamental principles of physics, and how it has had a lasting impact on modern science. Introduction to Planck's theory. What is Planck's theory? Planck's theory is a fundamental theory in modern physics that explains the quantization of energy. Specifically, it explains how energy is emitted in discrete packets, or quanta, rather than in a continuous stream. The theory was first proposed by Max Planck in 1900 and revolutionized our understanding of the physical world. Background and context: blackbody radiation. At the time of Planck's theory, there was a problem in understanding the behavior of blackbody radiation. Blackbody radiation is the emission of light from an object that absorbs all radiation that falls on it. Scientists had observed that the intensity and wavelength distribution of blackbody radiation did not agree with classical physics theories. The problem of black body radiation. What is black body radiation? Black body radiation is the emission of light from a perfect black body, which absorbs all electromagnetic radiation that falls on it. It emits radiation across all wavelengths, resulting in a characteristic spectral distribution. What was the problem with understanding black body radiation? The problem with understanding black body radiation was that classical physics theories predicted that the amount of radiation emitted would increase without limit as the wavelength decreased. However, experiments showed that there was a maximum amount of radiation emitted at a specific wavelength, and that the amount of radiation decreased as the wavelength decreased beyond that point. This discrepancy between theory and observation was known as the ultraviolet catastrophe. Planck's quantum hypothesis. What is the quantum hypothesis? The quantum hypothesis states that energy is emitted and absorbed in discrete packets called quanta. These quanta have a fixed amount of energy, which is determined by the frequency of the radiation. How did Planck develop the quantum hypothesis? Planck was able to develop the quantum hypothesis by assuming that electromagnetic radiation is emitted and absorbed by atoms in discrete packets. He used this assumption to derive a formula that agreed with the observed spectral distribution of blackbody radiation. This formula only made sense if he assumed that energy was emitted and absorbed in quanta. Explaining the photoelectric effect. What is the photoelectric effect? The photoelectric effect is the emission of electrons from a metal surface when light is shone on it. The energy of the light is transferred to the electrons, causing them to be emitted from the metal. How did Planck's theory explain the photoelectric effect? Planck's theory explained the photoelectric effect by assuming that light is made up of particles, photons, with fixed energy. When these photons strike a metal surface, they transfer their energy to electrons in the metal. If the energy of the photons is greater than the binding energy of the electrons in the metal, the electrons will be emitted from the metal. This explanation was a major breakthrough in understanding the behavior of light and paved the way for the development of quantum mechanics. The emergence of quantum mechanics. What is quantum mechanics? Quantum mechanics is a branch of physics that deals with the behavior of matter and energy at the atomic and subatomic levels. It focuses on the interactions between particles that are too small to be observed directly, such as electrons and photons. How did Planck's theory contribute to the development of quantum mechanics? In 1900, Max Planck proposed a revolutionary theory that energy is not continuous, but rather it is quantized, meaning that it is made up of discrete packets or quanta. This proposal was a major departure from classical physics and laid the foundation for the development of quantum mechanics. Planck's theory also helped to explain the phenomenon of blackbody radiation, which classical physics was unable to account for. Planck's impact on modern physics. What is Planck's legacy in modern physics? Max Planck's legacy in modern physics is significant. His theory of quantization revolutionized our understanding of energy and matter. It also paved the way for the development of quantum mechanics, which is now a fundamental part of physics. Planck's work earned him the Nobel Prize in Physics in 1918, and he is remembered as one of the most important physicists of the 20th century. How has Planck's theory influenced modern physics? Planck's theory of quantization laid the foundation for the development of quantum mechanics, which has since led to a number of important discoveries and technological advancements. Quantum mechanics has been used to explain phenomena such as superconductivity, tunneling, and quantum entanglement. It has also led to the development of technologies such as lasers, transistors, and magnetic resonance imaging, MRI. Criticisms and challenges to Planck's theory. What are the major criticisms of Planck's theory? One major criticism of Planck's theory is that it is based on empirical observations without a clear theoretical foundation. Additionally, some physicists have argued that quantization is not a fundamental property of nature, but rather a consequence of our limited ability to observe and measure energy and matter at very small scales. What challenges to Planck's theory have arisen over time? Over time, there have been several challenges to Planck's theory. For example, the development of quantum field theory in the 1930s and 40s introduced the concept of virtual particles and vacuum energy, which provide an alternative explanation for the quantization of energy. Additionally, the development of quantum mechanics led to a number of philosophical debates about the nature of reality, uncertainty, and determinism. Conclusion and significance of Planck's work. What is the significance of Planck's work? Max Planck's work was significant because it fundamentally changed our understanding of energy and matter. His theory of quantization laid the foundation for the development of quantum mechanics, which has since led to a number of important discoveries and technological advancements in fields such as electronics, chemistry, and materials science. How has Planck's theory impacted our understanding of the quantization of energy? Planck's theory of quantization revolutionized our understanding of energy by showing that it is not continuous, but rather quantized. This idea laid the foundation for quantum mechanics, which has since provided a more complete understanding of energy and matter at the atomic and subatomic levels. It has also led to the development of new technologies, such as lasers and MRI machines, which rely on the principles of quantum mechanics. Max Planck's theory of quantization of energy revolutionized our understanding of physics and paved the way for the development of quantum mechanics. Planck's contributions have had a lasting impact on modern science and continue to guide our understanding of the fundamental principles that govern the universe. Through his work, Planck demonstrated the power of creative thinking and the importance of pursuing scientific discoveries, even in the face of seemingly insurmountable challenges. In conclusion, Max Planck's theory of quantization was a groundbreaking contribution to the field of physics and helped revolutionize our understanding of energy, matter, and the universe as a whole. Without his theory, we wouldn't have the technology we have today, and we wouldn't have a deep understanding of some of the most fundamental principles of physics. We hope you've enjoyed this video and learned something new today. Stay tuned for more science explorations in the future. Thanks for watching.